My name is Puspendu Das. I am right now a professor at the Inorganic and Physical Chemistry Department at the Indian&France of Science. And I am here in this institute for about 36 years. I did my master in chemistry from IIT Kanpur in 1980. And then I went to Columbia University in New York in the United States and did PhD from Columbia University. And I finished in 1984. And then I went to University of Toronto to work in the area of chemical dynamics. It was at John Polanyi, and I was in Toronto for 2 years. And then at that time I applied for a job in India, and Indian&France of Science offered me a job as a lecturer in the Department of Inorganic and Physical Chemistry, and I came and joined here. After I joined, I was actually looking for various sources of funding in this country, and Indo-French Centre was in our notice because it actually started operating sometime in the 1990s. But as I was thinking of actually doing some work with some French collaborator, I came across someone in a conference in 2003 in Kochi, and her name is Mireille Blanchard-Desce, or in French they call it Mireille Blanchard-Desce. And she came after I gave a lecture in the conference and asked me if I would be interested in a collaboration with her on a topic of mutual interest. At that time I was looking at second order nonlinearities of chromophores and was using the technique called second harmonic light scattering technique in finding various physical properties in solution. At that point, we had done a work where we measured the critical micelle concentration of a surfactant using the second harmonic light scattering technique. And that aspect of our research interested her, and then she came and talked to me. So after that we decided. She was from University of Rennes in France, which is in the Brittany area of France. And she went back and then she actually wrote to me emails regarding how we can collaborate. And then after a couple of years of planning and thinking, we wrote a project sometime around 2006 on multi-supramolecular interactions in multi-chromophores. That was the title of our project. And in that, what we were trying to do is we were trying to look at molecular chromophores and arrange them in a particular geometry so that it becomes more than one molecule in a supramolecular entity. And we were trying to understand the hyperpolarizability of those molecules. The application of these highly hyperpolarizable molecules are many, particularly in the area of telecommunications and optical computing, also electro-optic communication and so on. But our interest was to demonstrate in the laboratory how one can arrange dipoles in a favorable configuration so that it creates a large second harmonic response. A second harmonic is if you shine light with some frequency omega, and if the light scatters frequency of light with 2 omega, then that's second harmonic of omega. And you measure the intensity of the second harmonic light and then try to understand at the molecular level how this hyperpolarizability of the molecule is increased or decreased. Now, at that time, what was known in the literature was that if you have molecular dipoles and if you arrange molecular dipoles in a parallel configuration, that means one reinforces the other, then you get a large second harmonic response from such molecules in solution. But then we were trying to figure out that there must be other geometries which are possible where you can actually get more than twice the response by arranging dipoles. So we actually wrote the project so that we were trying to arrange dipoles, and my collaborator Mireille, in her lab, she had a great synthetic skill, and she made molecules where we could actually arrange dipoles at different angles, for example 60 degrees, 45 degrees, and we could arrange dipole in two dipoles as a part of the molecule, three dipoles as a part of the molecule, and then in these supramolecular entities, we are then trying to understand what happens to the enhancement of the fundamental property which is related to hyperpolarizability called beta. And we found that we can actually get 3 times beta if we actually organize them at a particular angle. And that was the major thing. Now if we could therefore create a supramolecular infrastructure in a molecule where we could enhance this second harmonic property, this molecule would be very useful for various application purposes. So that was the aim, although our study was mostly fundamental in nature. And then of course the CEFIPRA project that was funded in 2007, now it was, I would say that it was generously funded in the scale of things that were happening at that time in other funding agencies in the country. For example, I was given the order of 27 lakhs for 3 years on this project, whereas my collaborator also got a postdoc and about 18,000 euros, okay, on her side for the project. Now, of course, we quickly worked on this project and we published several papers, but at the time of when the project was closed in 2009, we had about 5 publications from the project. Later on, we published some more papers, and this was considered as a successful project because those papers had a very high impact in the field in which we are working. And in the process also, there are 2 students who graduated from my group who actually worked on the main theme of this project. And at the same time, the postdoc who was hired by my collaborator in France, he graduated from IIT Kanpur, and then he worked with Mireille for 3 years under this project. And then he is now currently a faculty in the chemistry department of IIT&France. Okay. So overall, all the students who are involved in this project, they are all very nicely settled because the project actually did very well, and we are also very happy with this. And I think that in the Indo-French Centre has done a great job in running these CEFIPRA projects and identifying collaborators from both India and France and giving them opportunities to collaborate on topics which are of mutual interest, but it's not possible for one of them to do it by themselves. So that was the whole thing. So, for example, I could make the measurements in my laboratory, but I could not synthesize those molecules that we wanted to design. On the other hand, my collaborator could design those molecules in her laboratory in France, but she could not make the measurement because she didn't have the measurement set up there. So this was a perfect collaboration, and it was generously funded, and we actually utilized the funds fully well. And in the meantime, also we exchanged, people between the 2 labs. For example, a student of mine went and stayed in France for a couple of months, and the postdoc came and stayed here for a month. Then I visited my collaborator, she visited us, and in a sense, it was a very nice, very cordial project that actually ended up being a very successful project, I would say. And I think that among various Indo-X, X means another country, Indo-X projects, I think the Indo-French Centre has done the best job in terms of giving funds, in terms of giving the number of projects, in terms of giving the quantum of money, in all various aspects. This collaboration between the Indian side and the CNRS has been very successful, and I think this is one of the most successful Indo-X projects that has been ever done in this country, or so I believe.